Hello student, we learn about what are the uses of dimensional analysis to check the correctness of given physical equation. Second one is to find the conversion factor of the same physical quantity in different systems of units. And third use of dimensional analysis to establish the relationship between the related physical quantities. That are the uses of dimensional analysis. But some limitations of dimensional analysis. We learn about limitations of dimensional analysis. First limitation is the value of dimensionless constant can be obtained with the help of experiment. For example, kinetic energy. Kinetic energy is equal to mv square, relation between mass and velocity, but that proportionality constant half. Proportionality constant k is equal to half. That constant can be calculated by using experiment. Hence, that constants are dimensionless. Half is the dimension, half is the number. Numbers have no dimensions. Therefore, the value of dimensionless constant can be obtained with the help of experiment. Second limitation, dimensional analysis cannot be used to derive trigonometric, exponential and logarithmic functions. For example, you are given a function y is equal to a sine x, a sine omega t. Y is equal to a sine omega t. That terms, y is the distance, a is the distance and sine omega t. Therefore, that factor cannot find the dimensions. Sine omega t, trigonometric functions, exponential functions, y is equal to e raised to minus bt. Logarithmic function, y is equal to a log of x. That relations cannot be proved by using dimensional analysis. Third limitation, this method is not useful if constant of proportionality is not dimensionless. We see that example in a second use of dimensional analysis, the relationship between mass and distance. Therefore, according to Newton's law of gravitation, F is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Where that proportionality constant F is equal to G. G is the universal gravitational constant, m1, m2 upon r square, where G is not a constant, it's universal gravitational constant, but that constant have dimensions. G is equal to fr square upon m1, m2. Then we find out the dimensions of capital G. G is the universal gravitational constant. If the constant is only number, like kinetic energy is equal to half mv square, half is a constant, hence it has no dimension. But here G is the dimensionless quantity. If the proportionality useful, if constant of proportionality is not dimensionless, means it having dimensions, G having dimensions, therefore that constants find their dimensions. And fourth limitation, if the correct physical equation contains some more terms of the same dimension. For example, S is equal to UT plus half AT square. UT, their dimension is same, half AT square, their dimension is same. Therefore, if the particle is at rest initially, means T is equal to 0, U is equal to 0, therefore equation is S is equal to half AT square. That equation is also dimensionally correct. That equation is also dimensionally correct. Therefore, if the correct physical equation contains some more terms of the same dimensions, therefore that terms, the physical equation is dimensionally correct. For in each term, S is equal to UT is also dimensionally correct, and S is equal to half AT square, that is also dimensionally correct. These are the limitations of dimensional analysis.